In this video, I will show you how to take the graph of a periodic function like tangent, sine, cosine, cotangent, cosecant, and secant, and come up with an equation. It's going to be very fascinating. Alright, let's start with number 17. Our goal is to find a cosecant function. So let's see, might as well get started. Y equals cosecant. Blam. Laying it down. Now all we got to do is fill it in. We're halfway there. Might as well start with the midline because that's very useful. I see that, okay, the bottoms of these little valleys are right here, alright, and the tops of these little peaks are right here. So the midline has to be halfway between these two. Notice that these are 1, 2, 3, 4 apart. So the midline should be right down the middle. Alright, if I go like down 2, that should be the midline. So this is the midline right here. So the midline is -1. That tells me that my equation should have a -1 on the end of it. Furthermore, I see that from the midline it's 2 up and 2 down. So that means the a value is going to be 2. Well, it might be -2. I'll figure out whether it needs a negative sign later. Okay, now next it's time to decide what the b value is. Do I need a number right here? For that, I need to figure out what the period is, because those two are very closely related. So probably a good idea would be, let's go ahead and pick a pair of peaks or valleys. Oh, look at these. This would be an easy pair to use. Whoa, this is even better. Whoa. Slow down. Okay, I could pick any pair of peaks or valleys I want to figure out the period. But this one is right at 0. Alright, and then the next one's at pi. So that makes it easy to tell what the period is. Alright, because it clearly goes from 0 to pi. So that means that the period is simply pi. Okay? When it's not even like that, then I have to subtract the bigger one minus the smaller one. Like if I did one of these valleys, I might do 3 pi over 2 minus 1 pi over 2. That would be 2 pi over 2, which would also be pi. So anyway, the period is pi. So now I can find the b value, because we know that the period is going to be 2 pi over the b value. So that means pi is equal to 2 pi over the b value. So that means that the b value is 2 pi over pi. The pi's cancel, so the b value is 2. So that tells me that we need a 2 right here. Okay? So now it's time to figure out what the phase shift is. So I know what to put here. I need the x there, but so I know what to add or subtract. To figure out what that is, I'm going to need to do a sketch of the, let's see, this is cosecant, which is the reciprocal of the sine function. So I need to sketch myself a dotted sine function. Alright, maybe I'll use that pretty blue color I was using a moment ago. So the sine function, it has to hit these points. Alright, these peaks and valleys have to be hit. So I've got to respect that. Alright, and along the way it's going to have to hit the midline. So it's going to have to hit, alright, halfway in between, it's going to have to hit the midline as it goes. Alright, boom, boom, boom. So this is what appears to be happening. Oh yeah, I gotta make this dotted. Alright, it appears to be doing like this. Alright, it's got to connect with those peaks and valleys. Then on the way it has to hit that midline. So there you have it. Now you need to pick one period of this sine function. Okay, remember cosecant is the reciprocal of the sine function. So I need to look at this. I'm looking for one period of a sine function. Okay, let me see if I can make this a little bit smaller. So you can really pick any period of a sine function that you want, but whatever you're picking, it had better start on the midline. I'm liking this period right here that goes like this. Alright, it's the first like positive number I got to, so I'm comfortable with it. It's right in the middle of my graph, so that makes me like it. So I'm going to go with this one. If you pick a different period, like maybe if you pick the next one or the one before, that's just going to change your phase shift. Okay, but because of the one I picked, see how it starts at pi over 4? Okay, that tells me that this is the phase shift for this particular graph. If I look at this as a period, as like say the first period, then this would be the phase shift. Okay, pi over 4. So that's why I'm going to put x minus pi over 4 for the phase shift. Now, I mentioned at the beginning that maybe this would need a negative sign. That all depends on which period of the sine function you choose. Because I chose a right side up, a positive version, then I don't need a negative sign. If I had chosen a version that starts at negative pi over 4, then that one goes upside down first, so then I would need a negative sign. But this is one valid answer to the question. There are others, but this is one good one. For number 18, we're going to do a cotangent function. Okay, it's not quite as easy to see where the midline is when they just swerve like this so smoothly, but luckily it seems to me that the midline is the x-axis. Alright, this seems to be the point where it goes from curving one way to curving the other way. So these intersection points, it looks to me that the midline is the x-axis. So I know that's a little bit hard to see on a tangent or a cotangent graph, but we were nice to you and let it swerve right on the x-axis. So let's go with that. Let's talk asymptotes, people. The graph seems to be swerving towards these lines. Like this seems to be a vertical asymptote right here. Okay, and then here's another one right here. I can see up high and down low. The graph is swerving towards these lines. Okay, so here's another one, just another asymptote over there. Okay, now how far apart are these? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Alright, so the next asymptote is like off camera. Okay, anyway, that's important because that will help us to determine the period. Okay, so let's go ahead and figure out what the period is so we can figure out what the b value is. So for the period, I could either use the asymptotes and subtract those, or I could use these red dots you know, the x-intercepts, I could do it either way. Now I'm liking the dots because I'm noticing that they have the same denominator. Alright, so let's see if we can figure out what the period is. Alright, so the period, if I take the higher value minus the lower value, so that would be 7 pi over 6 minus 1 pi over 6. Uh-oh, you see what's going to happen? That's going to be 6 pi over 6. So the period is pi. Okay, the period is pi. Now for cotangent, the natural period is pi. So that means that the b value must be 1. So I've got y equals cotangent. Alright, normally I'd be thinking about having a b value right here, but it looks like there's not going to be a visible b value. The b value must be 1. Okay, now if you need me to follow through on that, I can do that. We know that the period is the natural period divided by the b value. In this case, the period is pi. So pi is equal to pi divided by that b value. If I swap these, I find that the b value is equal to pi over pi. So the b value is equal to 1. Hopefully it was obvious already, but there you go. The b value is 1, so we won't need any number in the front. Okay, the midline is the x-axis, so we won't need any number on the side. Let's go ahead and talk about the phase shift and get that out of the way. Alright, the phase shift. So for a cotangent function, you have to remember that a cotangent function begins and ends its period with an asymptote. Alright, so if this is going to be one period of the cotangent function, cotangent starts its period with an asymptote, it ends with an asymptote, and then there's a point right in the middle. So this is what I'm looking for. Asymptote, intercept, asymptote. Okay, so I just need to pick one of those. So I might as well pick the one staring me in the face right in the middle of the graph. Asymptote, intercept, asymptote. So this middle period, I'm going to look at this as my first period. Okay, so that means that this first asymptote is where it begins, and that's going to be the phase shift. So that's negative pi over 3. So since my phase shift is negative pi over 3, then I'm going to have x plus pi over 3. Okay, that only leaves one thing, the a value. Alright, this is going to be a little bit tricky. The a value, halfway between the intercept and the asymptote, the graph should be at the a value. So this is going to be a little bit tricky, but halfway between these 2 points, if I go up, halfway is right here, right? Halfway, like right here. If I go up and see where the graph is, bam, it seems to be right there. Okay, and same thing on the other side. If I go halfway between the intercept and the asymptote, that's right here. If I go down until I reach the graph, bam, that seems to be right here. Okay, so that should tell me what the a value is. Alright, let me just erase this nonsense out of the way. So it seems like the a value is 1. Alright, because we're at 1 and negative 1. Alright, when I went over halfway and I saw where the graph is, it's at 1 and negative 1. So the a value is 1. So I don't need to put a number here, but maybe I need a negative sign. So is this right side up for cotangent, or is it upside down? Well, the normal cotangent function, meaning just the original y equals cotangent x function, is always decreasing. Alright, it's always decreasing. It's always going downhill like this. Okay, decreasing. So, look at this graph. From left to right, this graph is increasing. Increasing. So, this is upside down. So, that tells me that there must be a reflection, a vertical reflection happening. So, I do need a negative sign in front of this, because that's the only reason to explain why it should be increasing instead of the usual decreasing. And that is it. That was a little bit tricky, but this would be a good equation for this cotangent graph. Alright, again, I could have picked this period over here on the left, or I could have picked this period on the right. Only thing that's really going to change is the phase shift. Okay, which could have been 2 pi over 3 or negative 4 pi over 3 instead of negative pi over 3. Everything else should really be the same. Alright, for number 19, they want us to do a sine function. Okay. I want to believe that should be relatively easy. So y is equal to sine. I'm just getting ready. Alright, now let's see what we've got. Let's start with the midline. Alright, maybe I'll just stick with this blue here. The high is at 3 and the low is at negative 1. That is 1, 2, 3, 4 units apart. Alright, so if I go down 2, that should be halfway. So that means this should be the midline right here at 1. Alright, so the midline is at 1. So I know I'm going to need a plus 1 on the end of my graph. Let's talk amplitude. From the midline, it's going up 2 and down 2. So that tells me that we're going to have an a value of 2. Maybe it's going to be negative 2. That depends on what period we choose to focus our eyes on. Okay, at a glance I can tell there's going to be a b value because the period is not simply 2 pi. So I'm going to leave space for a b value right there. So let's talk about the b value. To find the b value, I need to know what the period is. Okay, so one way to do the period is to go from peak to peak. Now most of these are not right on the lines, so that's not really helping me a bunch. Okay, well, let me try, let me see if I can find a beginning and end of a period that's like right on the lines. Alright, this problem is really tricky. I mean, I'm kind of surprised at the level of difficulty here. Here's what I'm going to do. I don't see a single period that falls right on the given x values. So I'm going to actually use 2 periods. Okay, and then just cut it in half. So here's 1 period, okay, of a sine function. Alright, that would be kind of an upside down sine function. Alright, but that's 1 period. I don't like the fact that it ends in between the lines. So that's why I'm going to keep going and do another period of the sine function. Alright, I'm not doing a very great job of tracing right now. You know what, that's not right on the lines either. Maybe I'll have to do a third. Alright, here comes a third period. And then I'll cut it in, I'll divide by 3. Alright, so here is a third period. Alright, this is really tricky. So I'm hoping that you can follow this. I'm having to do more than 1 period because of the way it's between the lines. So I really needed a way that it could begin and end right on the marks that we have. So, but understand that this is 3 periods worth. Okay, so 3 periods, 3 times the period, should be what I would get if I subtract the higher value, 9 pi over 4, minus the lower value of simply pi over 4. So 3 periods of this function should be 8 pi over 4. So that means 3 periods of this function should be 2 pi. So that means 1 period of this function would be what I get if I divided both sides by 3. Alright, so 1 period of this function is going to be 2 pi over 3. Okay, I'm trying to see if I'm really not seeing an easier way I could have done that. Anyway, if 1 period is 2 pi over 3, then now I need to find the b value. So 2 pi over 3, the period should equal 2 pi over the b value. Now normally I would swap these, but I'm hoping that it's just obvious. 2 pi over 3, what? That's not a good highlighter, hold on. 2 pi over 3, 2 pi over b. Guess what b is? B is 3. Alright, I'm hoping that that one just turned out to be obvious and that you don't actually have to do the whole swapping thing and do 2 pi over 3, and then you'd have to do 2 pi times 3 over 2 pi, and then the 2 pi's cancel. That's the long way. But b is 3. So that means we're going to need a 3 right here. Okay, great. Now we just need the phase shift. Alright, for the phase shift we just need to pick a period that we want to start with. It helps if it starts right on a number, okay, one of the given values. So I'm going to use the yellow period, even though it's upside down. That's fine. It's not a big deal. I like that it starts right on the mark. So that is pi over 4. So I will use that as my phase shift. So that means x minus pi over 4 would be right here. Because this is an upside down period that I'm using, I would need a negative sign to show the reflection over the y-axis. Okay, of course I could have picked other starting places. This negative 3 pi over 4, I could have used that if I wanted to. And in fact, if I did, that would be a positive version. Okay, I could have used 5 pi over 4 as the starting place. Okay, that would have been a positive version. So there's other choices I could have made. Alright, for this last one we're doing a secant function. So let's see, y is equal to secant. Alright, I am just getting ready. Remember that secant is the reciprocal of the cosine function. So just keep that in the back of your mind. Cosine function. Okay, they did not give us a lot to work with, man. Let's do the easiest things first. Let's talk about the amplitude and the midline. Alright, so look, I see the bottom of this valley and I see the top of this peak. So I know the midline has to be halfway between these two. This is at -4, that's at +2. That means these are 6 apart. So if I go down 3, that should be the middle. So this should be the midline right here. Alright, which also means that the A value should be up 3 and down 3. So the midline is here at -1. So that tells me that I need a -1 at the end of my graph. I saw that A value of 3 like I was just speaking about. It's up 3 and it's down 3. Okay, now I'm going to try to imagine a cosine function now, because when it's the reciprocal of the cosine function, we normally would start by graphing a dotted line version of the cosine function. So it would really help me if I could see that happening. So I know it's got to hit these 2 points. Now halfway between these, it's going to hit the midline. So I'm counting and I'm noticing 1, 2, 3, 4, 5, 6, 7, 8. Horizontally, these are 8 apart. So if I go over 4, 1, 2, 3, 4, this is where it should cross over the midline. So here comes the first part of my cosine function. Alright, it should be passing through the midline right there, and then coming back. And if I kept going, now again 1, 2, 3, 4, it should be hitting right here as well. Alright, now it's going off the graph, so that makes this a little bit tougher because it hasn't completed its cosine like look yet. So if I had space, it would go on and eventually get back to the midline, and that would complete my like cosine like look. So I'm gonna have to, in order to like talk about the period and such, I'm gonna have to go in the other direction because that's the only place I have space. So if I kept my my cosine graph going, it's gonna eventually, alright, 1, 2, 3, 4, it's gonna hit right here. So if I kept it going, it would look like this, okay, over here. And like look, if I switch and I look at this portion of the graph, alright, I feel like I'm cheating when I do this, because of course this this would be one period of a sine function, okay, because I'm starting on the midline. I should still be able to use this to decide what the period is, all right, you know, regardless of whether I look at the a period of the sine function or the cosine that I really wanted. The period should be the same. So I'm going to go ahead and cheat and use this to tell me the period because it fits on the graph. Okay, but then I'll go back to a cosine which has to start high when I talk about the phase shift. Okay, but the period though, these little marks are all multiples of pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Okay, so I'm mentioning that so I can get the final marks over here. So I can do the period. So if I went one more mark over, okay, this mark right here, I've got 11 pi over 4, so the next one would be 12 pi over 4. But wouldn't that be 3 pi? So this guy right here is 3 pi. Similarly, here I've got negative 3 pi over 4. If I went one more time, that would be negative 4 pi over 4. But wouldn't that be negative pi? So this guy right here would be negative pi. So look guys, if I'm going from negative 1 pi to positive 3 pi, how far apart is that? I'm hoping you could tell me just by common sense. Okay, from negative pi to positive 3 pi. But let's say if you can't just see the common sense, then I could subtract 3 pi minus negative pi. Alright, so that means the period is going to be 3 pi plus pi. So the period is 4 pi, which I hope you could see if I go 1 pi to the left and 3 pi to the right. That's a total of 4 pi. So the period is going to be 4 pi. Now the b value, because I'm building an equation, so I really need to know the b value. The b value, alright, we know that the period is going to be 2 pi over the b value. That means the b value is going to be 2 pi over the period. Okay, so the b value is 2 pi over 4 pi. The pi's cancel out, and we get a b value of 1/2. Alright, so that tells me that we're going to have a b value of 1/2. Okay, so all that leaves is the phase shift. So I'm going to go ahead and put x right here. So this will be like x plus the phase shift or x minus the phase shift, whatever it is. And I need to decide if it needs a negative sign in front. So I cheated. In order to find the period, I highlighted a period of a sine function. But I can't really do that for the phase shift. I have to look at a period of the cosine function. Or at least I need to see where a cosine function would start. So I kind of was talking about this before. This is trying to be my cosine function. Alright, this is what I really wanted to use, except I ran off the graph. Okay? So I couldn't use it for the period, but I can still use it for the phase shift. Alright, because you can still see where it starts. And conveniently, it starts right at 0. So that means there is no phase shift. So that means I don't actually need to put a value here. So that means I have extra parentheses I don't need. So let me clean this up a little bit. So I could just have 1/2 x minus 1. Alright, no phase shift required. And this is a positive version of a cosine function. Alright, it's upward turning. So I don't need a negative sign either. So that means this is the final answer for number 20. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.